just wanted to walk you a little bit through responsible ML journey within Microsoft, but with a focus on the two packages that I'm driving the product efforts within Azure AI and Microsoft Research as a joint collaboration, which are, as Krishnaram kindly mentioned, InterpretML and Fairlearn. We're all here because we care about responsible AI, but why responsible AI in general? Something that I really liked from the book Tools and Weapons that really talks about how Microsoft President Brad Smith really thinks about responsible AI is the more powerful the tool, the greater the benefit or damage it can cause. So of course, with any impact that you're having on people's lives, it really comes to responsibility of not how to use it, but where to use your power and how to affect people's lives. So responsible AI, we are pretty much seeing it as a real challenge for many of our customers. As also it was reported in Capgemini report that with reporting 9 out of 10 executives across the whole globe. So it's like, as you can see, a global study that they've done. And it was reported that nearly 9 out of 10 executives have reported facing with some form of ethical issues when it comes to implementation or deployment of AI. So there are so many reasons that they cited in this study, but among them, the executives cited reasons including the pressure to urgently implement AI, the failure to consider ethics when constructing AI systems, and really lack of access to practical tools to ensure that the AI is being developed and deployed responsibly. So we saw that as an opportunity to come up with, of course, tools that are really also considering the socio-technical aspect. And hence, I'm highlighting 2 of them in our today's presentation. Now, taking a step back, let's see how the responsible AI journey started within the company. Now, almost near 4 years ago, Satya Nadella, our CEO, basically penned an article in the Slate magazine that was titled The Partnership of the Future. And in this article, he introduced concepts of transparency, efficiency, etc., but not at the expense of dignity of people, intelligent privacy, algorithmic accountability, and protection against bias. I would say about a year or shortly after, we formed our AI Ethics Committee, which is called Ether, and it's short for AI Ethics and Effect in Engineering and Research, which has many different working groups underneath. Each of these working groups are focusing on one particular concept, maybe fairness, transparency, sensitive use cases, security, etc. And of course, Ether spent a lot of time listening to customer, internal experts, and then partner with legal affairs to publish The Future Computed in January 2018. And then Microsoft called for a lot of regulations, specifically in the space of facial recognition in July 2018. And the principle published around December 2018. And around 2019, Office of Responsible AI within Microsoft was formed and published a set of internal standards for responsible AI that internal teams basically should very, very closely follow when they want to develop or deploy artificial intelligence systems. Now, to put our principles into practice, we've also developed a set of tools to help others understand, protect, and control their AI at every stage of innovation. Our results are basically these tools. A lot of them are available externally. Like AI Business School has a lot of great resources that you absolutely should check if you haven't. And they're really aligned with both data science concepts, but also how to develop and deploy AI systems responsibly. The Office of Responsible AI also has a public-facing website with many, many great practical tools and tutorials and case studies regarding the responsible AI. So I really recommend you taking a look at the Office of Responsible AI page as well. And eventually, the messaging that we announced at Microsoft Build about a month or 2 months ago was really 3 different buckets that we would like to make sure we have practical tools for. And one is understand, to basically understand your ML lifecycle better. Then protect, how to make sure that, of course, data is not just data. Data is representing people. How to making sure that the data is confidential, the ML pipeline, and the confidentiality of many, many different machine learning problems end-to-end is staying completely true and hidden from the eyes of either a hacker or even internal people, data scientists, etc., who are not supposed to access those type of information directly, things like eyes-off training, etc., and also control, how to make sure that people are held accountable end-to-end for training models, can control their path, can audit their path, can monitor their path, etc. So the focus of today's call is mostly on the understand bucket. And the understand bucket is really well aligned with some aspects of or a lot of aspects of the AI principles that we have in place. And by no means this Microsoft AI principles is the ground truth or anything. I'm sure every single company that you are from has its own set of AI principles that is wonderful and is being practiced internally. But within Microsoft, these are the set of AI principles that we believe should really inform the development and deployment of AI systems in a responsible way. And those are fairness, reliability and safety, privacy and security, inclusiveness, underpinned by two foundational ones, transparency and accountability. And first, I'm going to start with basically transparency and interpretability, and I'll share my slides. You can take a look at our OSS website, the tutorial video, customer highlight in order for you to see how InterpretML has been used in an end-to-end customer use case. But we introduced a tool called InterpretML less than a year ago. And if you check out interpret.ml, it's going to take you to a landing page. The goal of it is really to understanding and debugging models. And the biggest value prop behind it is we work with many customers from a specifically heavy regulated space, and we realize that one of the biggest challenges that they have is, one, they have a hard time proving that their model is doing what it's supposed to do based on the signals that it makes sense rather than problematic patterns to their non-technical stakeholders or business stakeholders, etc. They also have a hard time to audit their models, to understand what went wrong inside the model and how to improve it and take the next steps to take it to the next level. And last but not least, they wanted a way to ensure that the model is making its decisions based on roughly fair insights and is not considering the sensitive attributes of people as a hugely important signal to make its predictions. So they had no way of really having these signals without interpretability toolkits. And then taking a step back, so far everything that I have focused on about interpretability is really about interpretability on training time. But taking a step back, even at scoring time or inferencing time, people put out the model there, they put it out there, and then they have no idea how the model is impacting people's lives in the real world. So of course, when you put the model out there, you bear this responsibility to provide them with a lot of why answers, right? They come to you and they ask, why my model has got rejected? You should have this insight as, oh, based on this signal, that signal, that signal, the model has provided this particular decision to your use case. And when you think about GDPR's right to explanation, that is also talking about the same concept as whoever's legal status is being affected by an AI system at scoring time or at inferencing time has the right to go and ask why. And this, for instance, one of these toolkits are supposed to provide you with also interpretability insights at scoring time. Now, right off the bat, when you land on the interpret.ml and go to the GitHub, there are 4 different repositories that you will see underneath that, and 2 of them are mostly for interpretability technique for tabular data. I'll explain what is included momentarily. Then we have expanded it to NLP scenarios. We started with text classifications. A lot more scenarios will come soon, but also if you have a particular NLP scenario that needs interpretability, definitely feel free to reach out to me on LinkedIn, etc., and I'll be super happy to see what we can do for your use cases. Then we have DICE, which is diverse counterfactual explanation, which basically talks about who is the closest person to my data point, which has received a different outcome from the model. Or you can also take a look at it this way. What is the minimum change that should happen to my data point in order to make me qualified for the loan? In case I'm rejected right now. And then I'm also going to very briefly touch on what aspect of it has been integrated within Azure Machine Learning. So focusing on tabular data interpretability, we cover a collection of glass box models that are intrinsically interpretable model and black box explainers that can basically sit on top of any black box model that you have, no matter it's a traditional machine learning model or a deep neural network model like PyTorch, TensorFlow, and Keras. Among our glass box models, we are very proud of Explainable Boosting Machine, or EBM. If you check out the Interpret README, you will see that this is a very unique contribution from Microsoft Research to this open source repo. And that's the only interpretable model at the moment with very, very comparable accuracy and efficiency to known models like BloodGBM, XGBoost, etc., but also completely transparent inside out and very lossless. So it models the interactions between features. It also models a higher degree of dependence of output to input features. And the idea is based on generalized additive models. Among our black box interpretability techniques, we're bringing many proven third-party or Microsoft Research interpretability techniques under one set of APIs, so you can call all of them, compare the results. We do have an interactive visualization dashboard where you can see your model performance, you can see your data exploration, and I really briefly show that to you. So basically, you can see your model performance. You can also add cohorts and see your model performance across different cohorts. For instance, like if you want to have only females, only males, and see how the model is treating them. You can look at your dataset statistics. You can look at your top K important factors and click and see how those factors are impacting your model prediction. And eventually, you can look at individual feature importance or local explanation. Click on a particular data point, look at the local explanation for that particular decision that the model is making, and also performing perturbations or what-if analysis. These are basically built with the, and I'm trying to go back to, sorry. So these are all available to you within, as I said, our open source offering, absolutely for free. And I'll talk about what aspects we have integrated within Azure ML. But let's briefly talk about our fairness offering, which is another open source offering, and we call it Fairlearn. The idea behind it is there are many ways that AI systems can behave unfairly. There are so many types of harm that AI can give rise to. And two very common, one among like many different types of harm, is harm of quality of service and harm of allocation. Now, harm of allocation is when your AI system is withholding or providing opportunities, information, or resources from people. Like one major example of it is, say, a model for screening loan or job application might be much better at picking good candidates among white men compared to some other groups. The other type that I would like to highlight is harm of quality of service, where you would receive a different quality of service from the AI system only because of your sensitive attributes. And one example of it can be a voice recognition system might fail to work as well for women as it does for men. Or another very famous example of it is facial recognition systems developed by some very known companies out there, including Microsoft itself, were reported to have lower accuracy on females with darker skin tones. So this is only because of the fact that you're a female with darker skin tone, you're receiving a completely different quality of service from this face identification system compared to, say, a white male. So the goal of this project was really to avoiding negative outcomes of AI systems for different groups of people. Now, I should put a huge disclaimer out there that fairness is a socio-technical concept, and many aspects of it, like justice and due process, etc., cannot even be understood or measured by AI. First, this is a topic that is being studied by philosophers, social scientists, psychologists, like et cetera, for decades and centuries. So we suddenly can't come from the tech world and say we have a solution for it. But we believe that there are some aspects of it when it comes to these particular two types of harms in our data set, in our toolkit, that we can at least measure, and we can take steps towards mitigating that. And that's why our toolkit consists of two different phases, fairness assessment, and we provide another interactive dashboard that I momentarily show you, where you pick your sensitive attribute, and then you can measure some different fairness metrics on top of your basic demographics that you chose. It can be female versus males, it can be different income groups, it can be different age groups, it can be different races or ethnicities, different sexual orientation, etc. And then after you measure that and you observe and uncover some potential fairness issues that are happening in your model, some potential subgroups that are negatively impacted by your AI system, you can, of course, go back all the way to the beginning of your ML lifecycle, observe your data, augment and enhance your data, get rid of some trash data and augment it with better data, maybe represent some underrepresented groups better, etc. And go through your model collection, data collection phase, make sure that it's not introducing some unfairness, go through your model training, etc. But as your last hope, if you have done all these things and you're still observing some fairness issues, we are also providing a set of state-of-the-art mitigation algorithms from Microsoft Research New York City as a part of this toolkit, where you can load these, they basically act as a wrapper on top of your ML algorithm, and call your model, reweight or relabel your data multiple times with respect to a fairness constraint that you pass to your mitigation. For instance, you can say, I want to mitigate unfairness with respect to demographic parity or equalized odds or equal opportunity, etc., etc. And there are multiple of them that we support, or say bounded group loss for regression case. And then based on that criteria that you have passed to the mitigation algorithm, that goes through the mitigation. Each time provides you with a model. And then at the very end of the day, you have a set of models that you can compare to your original model. And you can see the performance versus the fairness trade-off there. And as a stakeholder, you can choose which model is more appropriate for your use case. How much performance, is there a trade-off? Maybe yes. How much accuracy or performance you can sacrifice in order to improve fairness, etc. And so in your context, you can decide how to move forward with this. And so the way that it works is basically you bring your input and you specify the sensitive attributes and the performance metric of interest. Then you basically go through the assessment phase and you look at the disparity in your performance depending on what type of performance metric you've selected, the distribution of errors across your subgroups, and also you look at the disparity in selection rate, what percentage of people have been selected to get the favorable outcome, and then you can use mitigation algorithms depending on how you want to use that, whether you are allowed to touch the machine learning model or not. If yeah, if no, post-processing algorithms to sit on top of your model prediction. If yes, then reduction algorithms, which basically goes through the multiple times of retraining your model with respect to a fairness constraint. And you can use them in order to alleviate the unfairness that you're observing. Now, our team believes in an open source approach. We strongly believe that responsible AI is a brand new booming field that is basically needs to be considered in every single life cycle, whether you're coming from a heavily regulated space or not. And because of that vision that we have, we started everything in the open source. So please feel free to try it. Fairlearn.org, Interpret.ml are the two landing pages that we have for these two toolkits. But in order to empower the customers and users that we have on Azure Machine Learning, we also have integrated it within Azure Machine Learning. So basically the way that it works is without these nodes, this is how Azure Machine Learning lifecycle works. It has training and deployment. You bring in scripts and then you execute it on a compute target. It can be a CPU, GPU, etc. After each run, all the run records are going to be stored in Azure Machine Learning run history, which is like a module to save your model basically assets and all the metadata around that. You go back and forth and you take a look at your model, maybe tune it again or improve your data, etc., and go through this life cycle multiple times until you feel comfortable about your model. And then you go ahead to the deployment phase, register it, create an image, and deploy it for scoring time. And what we are providing to you is we have incorporated these open source offerings within Azure ML. So as a part of your training, you can also generate explanation and model fairness insights, and you have the functionality to upload them to Azure Machine Learning Run History. And this way we support interpretability and fairness as a part of Azure Machine Learning SDK and Studio, which is an framework or basically a toolkit, visual toolkit that we have for you to manage all your assets in one place. And then you go ahead and you register your model, but also you register the corresponding explainer alongside that. You provide an image or create a Docker image of both, and you deploy both. So at scoring time, you can call the deployed model, get the prediction, but also you can get the deployed explainers and get the explanations. And this way, we're really hoping that our customers who are on Azure Machine Learning can also incorporate these type of practical tools actively in their ML lifecycle. And yeah, this is some tools for the Azure Machine Learning integrations. If you want the open source one, fairlearn.org and interpret.ml are the links that takes you to the landing page, the user guide, and the GitHub page.